Okay, we're going to have a look at one last type of function to differentiate, and that's logarithmic functions. So in the previous few videos we've looked at, well, differentiating exponential functions. So when we differentiate e to the power of x, we get e to the power of x. Differentiate e to the power of ax, we get ae to the power of ax. And now when we differentiate the natural log of x, so remember the natural log of x is log to the base e of x. That's what it means. That's the same thing. So instead of writing log to the base e, I can write ln, the natural log of x. So when I differentiate the natural log of x, I get 1 over x. And then one other function, when I differentiate something that looks like this, a to the power of x, so some like 2 to the power of x, or some constant to the power of x, I get a to the power of x times the natural log of a. So very, very simple to differentiate logarithmic natural log functions. So let's have a look at a few examples. So we want to differentiate the following. The first one, x multiplied by ln x. So you should notice by now that we have a product here. So, okay, let's have a look. So we want to differentiate, let's say f of x is equal to x ln x. So we have a product, so we're going to use the product rule. And by the product rule, we say u of x is equal to the first part of the product, so x, and v of x is equal to the second part of the product, so the natural log of x. Easy to find u dash x. Differentiate x, I get 1. Find v dash x. Well, differentiate ln x, the natural log of x, I get 1 over x. Okay, so we have 1 over x. And then by the product rule, f dash x is just equal to u of x times v dash x plus v of x times u dash x. So it's going to be x by 1 over x plus, so u of x v dash x ln x, the natural log of x, times 1. So we end up, just to tidy that up, x by 1 over x, well, you should be able to see that that's equal to 1. I'll just show you down here just in case you don't know. So we have x times 1 over x. X times 1 over x is the same as x over 1 times 1 over x. So if I multiply them top by top, x by 1 I get x, over 1 by x I get x, so x over x is 1. So that's where that's coming from. So x by 1 over x gives me 1, and ln x by 1 is just ln x. So we have here. So to differentiate this, I use the product rule, and I got this down here. Okay, the second one, we're differentiating the natural log of x squared, so ln x squared. So let's say f of x is equal to ln x squared. Well, we know to differentiate the natural log of x, we get 1 over x, but this isn't quite that. This is the natural log of x squared, so we're going to have to use the chain rule on this. So by the chain rule, I can say h of x, we've got two functions. We've got the x squared function, and we got the natural log function. So h of x is x squared, and let's say g of x is the natural log function. So it's ln of x squared, so x squared is h of x, so ln of h of x. And it's easy to differentiate these two individually. So h dash x, differentiate x squared, and we get 2x, and differentiate g of x. So to differentiate the natural log of something, so ln x, natural log of something, h of x, I get 1 over x, so g dash x will be 1 over h of x, which in this case, well, h of x is x squared, I get 1 over x squared. So by the chain rule, I have f dash x is equal to, it'll be h dash x times g dash x, which is 2x times 1 over x squared, 1 over x squared. So multiply them out, I get 2x over x squared. I could simplify that fraction. I can divide top and bottom by, well, I could divide top and bottom by x, so we end up with 2 over x. Okay, so we're almost finished. Well, I've shown you how to differentiate all the different types of functions now that you'll be asked to differentiate. So here they all are. So to differentiate x to the power of n, we get this. Ax to the power of n, we get this. Remember, a constant differentiates to give us 0. We've had the e to the power of x, e to the power of ax. The natural log of x we just had differentiates to give 1 over x. A to the power of x differentiates to give a to the power of x ln a. So for example, let's do an example of that one. So say we have f of x is equal to, let's say, 2 to the power of x. So that looks like this rule here. So to find f dash x here, I just guess 2 to the power of x will differentiate to give 2 to the power of x times the natural log of 2. So 2 to the power of x ln 2. And you can just leave your answer as that. That's fine. So we have all of these functions so far. We have the trigonometric functions, sine, cos, and tan, and what they differentiate to give us. We've got the inverse trigonometric functions. So cos inverse x over a differentiates to give this, sine inverse x over a differentiates to give this, and tan inverse x over a, I couldn't fit it down here, differentiates to give this. So they're all the different types of functions that you can be asked to differentiate.